Good evening,
Nice.
everyone. So it only works if you press the go live button, right? So we were halfway in this talk, and then nothing was there. So we start over again. Welcome, everybody. Thank you for waiting. Welcome to another Go Azure meetup. We were in a talk about K6 and load testing on Azure because things are changing and we need to keep load testing. So Jose is here in order to talk about that. Bram down under is helping me with all the technical stuff and chatting and everything, which is strange tonight, but hey, it was a long day. We will not keep you waiting any longer. We will jump right in. So the floor is for Jose.
All right. Thank you, Daniel. Amazing introduction again. So, goede avond. I think that's good evening in Dutch. So, have a nice evening, everybody. And today we are going to dive into performance testing from zero to hero with K6 and Azure DevOps, of course. So the first thing is, why should you listen to me? My name is José Luis Latorre. I work at Swiss Life as a software architect and as developer community lead, helping they're into bringing the community, getting them excited about new technology and Azure and everything coding. My GitHub is GOSLAT, which comes from my name, and my Twitter ID is GOSLAT as well. I've been a 9-year MVP, which shows a bit my passion for technology until work hit and then was not collaborating that much. So I'm not anymore at that moment. And yeah, I'm a software architect. I've been pushing through performance tests inside the company. They are quite good. We're doing that with K6 and yeah. Also, I am the .NET user group lead in Zurich. So we founded that in 2012, end of 2012, beginning 2013. And I'm leading that together with other friends. And that's about it for now. And today it's about everything performance. So first, I want to convince you why we should do performance testing, why K6 is a very, very good option. I will make a hands-on introduction to K6, and then we will see how to integrate K6 with Azure DevOps. And we will take a look at the template, which is an open source project that's, well, open source for everybody that wants to dive into K6 and performance testing. So let's get to it. Why should we do performance testing, if at all? It costs money, it takes time, it's difficult. I mean, Daniel said something before that's very, very key. Everybody, we should do it. And he's right. If you like control, you like to be in power and not have stress, not have overnights or weekends dedicated to fix issues when you jump into production, you should do that. Several reasons is that even our testing pyramid seems complete, and a lot of people in the market are not doing that. Everybody thinks that the test pyramid is enough, but that's far from it. Unit tests are good, integration are great, and end-to-end tests or GUI tests are also amazing. They are needed, but they are functional. Usually, we are testing all of that for only one user, and performance is simply not there, so we should add it. Also, some people will say, hey, that will cost even more than the end-to-end test. Well, what happens, right, if you don't do that? We all know it if you have been a few years in IT, Murphy lives. And performance tests are key to identify real-life production problems. It's where you can simulate the amount of users you have. Instead of testing end-to-end tests with one user, you can do that with 100, 1,000, 10, 100,000. Well, it depends what are your needs, but you should try that out unless you want surprises. Once upon a time, and this happened to me in a project I was, after like 6 or 7 years, maybe more, in a project under development, we discovered an issue, which I will not disclose. And only the mitigation part costed more than $2 million. The project was delayed. There was a commercial loss that it's not evaluated here. So, well, that's quite a bit of money. That could have been easily detected if performance tests or load tests were in place. Another thing is the Samsung Note 7 battery costed about $70 million. Apart from the risk of losing a leg, some people got very serious burns. So, well, unless you want something to explode, your code can kill people, or lack of testing can, right? So testing production, what can go wrong? Or close to production. I mean, would you dare to put a project in production having done just a single test? Probably most of you would say, no way. And I would say, yes, I agree. But usually you're doing that if you're not doing performance tests, because you're not doing a single performance test for the amount of users that your software will have. Summary, it is worth it. Ensures reliability, project success, shows the brittleness of your application, verifies service level agreements, which is the same as non-functional agreements, like performance, response time, the amount of users that it can scale up or scale down properly. And at the end, it saves money because it detects the issues as soon as they are produced. If you apply performance and load tests since day 0, it's really, really like that. On the projects that I have been able to do that, the issues are detected right when they are added, and saves us developers from a lot of stress. I mean, fixing something as soon as it is added has no value, and the cost is really, really teeny. So a similar issue later on my career, that the one that costed $2 million, one architect like 1.5 years, and one team like 2 or 3 months dedicated to to mitigate it. That's a huge cost. And a similar issue in another project costed me 1 week only of my time. Well, and there are some studies of the cost of fixing defects. And well, if you fix them in production, you can see that it scales in a very, very bad way and is really, really costly. Well, summarizing, it's the best way to discover hidden, hard to fix issues. And I would say it's the only way. It saves money a lot and also stress. So do it. Next point is, why should you use K6? K6 is a tool for doing performance and load testing. You can do code-based testing with it. And some points for the decision I took for picking this tool were the performance comparisons, put it really good. It is open source. It is code-based, so you can put your code in your CI/CD pipeline. Integrates fantastically with any DevOps tool that you can have. And it's really, really easy to use. I could myself even learn myself how to use it very quickly. And it has many outputs and integrations. And if there is none, you can extend it. So it's extensible. Apart from that, it's modern. So it's more or less about 5 years ago created. It's not based in a UI. Having a UI determines a lot, and it's not good. So the only thing you have to give it is your code. And it's pretty active in terms of commits and releases. It has really, really very constant releases. I was checking a bit the GitHub because it's also open source. And it's really amazing the amount of releases that they have done. It's really good. And they have also very good performance. So ratio of, this is taken from some years ago. This is RPS, which is records per second, versus the memory used in this case. So 67 megabyte for 11,300 records per second, which is pretty good. All right, then we're going now to take a look at how to do things with K6. We will be asking ourselves a bit, how do I begin? How does it work? What's the lifetime of K6? How to simulate a user? Verify, for example, that our duration of the HTTP request is 300 milliseconds, for example. How to do a make pass-fail test to verify the test. And at the end, how to simulate real-world load. That's really, really tricky in some other performance or load test tools. And finally, we will see how to integrate it with Azure DevOps. So where to start? Well, obviously, we have only one thing to do. It's hello world here. So have here some code. Daniel? Perfect, thanks. So here, the first thing we have to do is write sorry in JavaScript. K6 is built on Go, but you code the test in pure JavaScript, which if you're a .NET developer, it feels really, really familiar. There is a plugin for doing that, but I really like to write it natively. And yeah, for a simple hello world, you do import HTTP from K6/HTTP, you import the sleep module from K6, and then you export a default function, which is when you call K6, what will be executed. Then you assign the results to HTTP GET of this URL. This endpoint is a test API, a point that K6 has, so it's perfectly fine to hit it and to do your test with it, so don't worry about that. And then I do a sleep 1. How will this look? And first, how do you do that? So the directory, and first you have to type K6 space run, then the name of the script, and essentially that's everything. So let's take a look. How does it look? So let's make it a bit bigger, and that's it. This script did only one request, one iteration for one VU. VU starts for virtual user, so it simulated one user. And here we have some data. We get a green here mark. Usually if you add a check, or we will see a bit more later, you will get some green marks around for the scenarios, but it's using the default scenario. This is what is invoked when we execute this function that we saw, the default function. It uses the default scenario. And then we get some statistics, some trends for the HTTP, like how much time it was blocked, but the key one is the duration, this one. Here we can see the average, the minimum, the median, and the maximum. Also a percentage of 90% or 95%. And then we can see how many iterations and how many VUs, virtual users, we did use. Pretty simple so far. So let's get back to it. Then next question is, how does it work? For that, we have the concept of lifetime, which shows us a bit when do the things happen in K6 when we do a script, which is fundamental. When we want to code something, we want to know how does it work. Have another example here where I do the same, import HTTP, import the sleep. I have a setup function here, and I'm simply doing a console log. But here is a step where you would prepare, if you want to use only a login and get a token to authenticate, you would do that in the setup, which is executed the first thing. That's the one. Then you would do the different scenarios, and you have here the default function as before, and you have here to virtual user code, or the work. The main part of the test would be happening here. And then at the end, the tear down. So if you propose or put some resources or created something, you should clean it up here. Run this script. We can see here the logs. We get one, the setup, the view code, and then the tear down. Obviously, we did only one request. If we had more than one, this would have been printed a lot more times. And here we can see the different sections as well. So now that we have that, we will probably want to, how do I simulate a user, check that something is happening in the time that I want, do what we call a check. Well, that is done with the views, duration, checks, and options. I have another example here, which is this one. We have a variable that is part of case 6. This is where we define the options for execution for case 6. So we do export let options, and here we can put the virtual users. In this case, we want 2 virtual users, and we want this to happen during 5 seconds. And then the false function. This will make that the default function happens for 5 seconds, and we'll have 2 virtual users trying things in parallel. So and everything is taken care of by case 6. And then inside of it, we do the usual. We do a HTTP GET, but then we get this result, this outcome, and we check that, okay, we got a 200. And also that the duration was lower than 500 milliseconds, and sleep 1 second. To see how this works, we can do the same. It's 3. Hit it. Now you can see the bar is progressing, showing what is happening, and we executed 8 iterations and simulating 2 virtual users. And then we got the checks that went green, so the test service is behaving properly. That's good. Here we get again the iterations, and again the request duration, HTTP request duration, that goes from 96 milliseconds, not that performant, to maximum of 108, which is not that bad if we compare our limit of 500. So then we would like to do a fail pass test. So if we put that in, for example, Azure DevOps, and we would like to say, hey, everything is good or it fails, we may think, oh, but don't the checks do that? No, the checks do a check, but they don't fail the test at all. What works for that is called a threshold. We put a threshold like an umbral, and we define it. But where do we do that? Again, in the options. So let's take a look to it. In the thresholds, you can see that the options is, again, a bit bigger. We put 5 virtual users. Here, I use the same, so sleep and check that I used on the previous. So here, this is completely unchanged. I put, again, a duration of 5 seconds to be quick. And here, I define the thresholds. And here, I can put 1 or different. So that's an array of JavaScript elements. I gave them a name. And essentially, I tell, OK, I want that the HTTP request duration, that 95% should be lower than 200 milliseconds. And I want that all the checks 90% of them should pass. And then the rest is absolutely the same. So that's a 4. We do a K6 run 04, thresholds. And again, we are executing, but this time we have a threshold, and the threshold passes. So the difference with the one before is that here we get some different marks. But if we execute that inside of a test in Azure DevOps, we will get a NAI or YAI. You get what I mean, I hope. So now we are ready for the big thing, simulating the real world. At the moment, we have done just one request. We have done a request for 5 seconds. We have put some checks, simulated a bit more than 1 or 2 users, but then also put, OK, a fail pass condition with the thresholds, which is good, right? This simulate real world is done with the stages. Stages are the way to define how the load changes over time, because you know reality is complex. So stages, again, in the options. So we got another collection here, which we can, in this case, create an array of duration and the target. The target in this case is views. So I want 5 users to be simulated, and then I want 10 users, then 5 and 1. One thing is that we are doing a ramping views by default as an executor. I'll tell a bit more about that, but there is the way that we are assigning the virtual users over time or the iterations is called executor. And this is changing over time. Here, by default, is a view, ramping views, and we will go initially, if we don't put, from 0 to 5, and then to 10, and this will go up, up, up until it reaches 10, and then down to 5. We will see how it goes. This is a 10-second test, and we will execute it in a moment. Okay, 6, run, 0, 6, sorry, 5 stages. Let's go. You can see it's evolving 5, 7, so it's gradually ramping up, and now we'll ramp down again, and then to 0. Perfect. Good. So that's how it goes. So the views went from 2 to 10, and we executed 54 iterations, and the same thresholds than before. So now we did something a bit more serious, like how the users would get in your application, start doing requests, and stay a bit on the maximum. In this case, it's 10 virtual users per second, and then go and do a bit of a ramp down. That's one thing. Then we have the concept of scenarios. Scenarios allow us to map the real life usage because, okay, simulating the load, how it evolves, stays, grows, and then goes down is good. But a user, probably your users will do different things in your application or in your API. And this is what the scenarios allow to do. So we can set different scenarios that will happen when we want and how we want. We can bound them to its own executor and custom function. And this gets a bit more complicated. Let's take a look. Here we have the same, but we have a scenarios defined. And here each scenario is an object that contains also stages. In this case, this scenario, we call it get crocodiles, which is a fun fact from K6. The original startup had 2 crocodiles in the company, so their web services and their logos still have crocodiles in the image. And I think they don't have them anymore, but that's true. They had crocodiles in the office, so it's quite an interesting fact. And in this case, I'm using executor ramping views, which is the default one. I started at 0 seconds, so I could start it a bit later, like the next one. And the starting virtual users are 1, and I have only one stage that will go in 5 seconds to 5 virtual users. The next will get context, and I call it get context. And I use the same executor. It will start on 3 seconds. It will start with 5 virtual users, and then stay with 5 virtual users during 2 seconds. And then I create, instead of a default function, I create a function for each scenario. One will get the crocodiles, and the other will get the context. And I don't do any check here. This is just to show a bit this. By the way, after this, you will get the link where all this code is. All right, so let's take a look and how it works. K6, run, and then 0, 6 scenarios. And we do that. Here shows some information of the scenarios and shows this one, a scenario get crocodiles, scenario get context, and you can see the evolution of them. I will execute it a bit more so you can focus on these lanes and see that they also show properly when they start or not. You can see now it's crocodiles, 3 seconds, and the other starts. Bam, it's done. And we did 195 requests, which is not bad for 5 seconds. All right. Almost done, not yet. Next thing is executors. Executors is how do we execute the things? How do we execute the different scenarios? We saw the ramping virtual users, ramping view, but there are some more. So the ramping view is the same that you saw. We simply name it ramping view, and it will ramp up and ramp down. So initially it's 0, it will ramp up to 25, and then it will ramp down to 0. I think the best thing is that we see it. Okay, things run 07. You can see here, it ramps up to 25, and after it will simply ramp down to 0. That's it, nothing more. There's another concept, which is close versus open. So last year, they created the open. At the moment, or until now, until mid of last year, I think it was about end of June or mid to end of June last year, K6, they only had the closed model, which was working with virtual users. The problem with the closed model is that if you have one virtual user and your server stops responding, this user is stuck. It's stuck waiting for the server to respond and will do nothing. An open model doesn't care about that. It only cares about sending requests to the test system, which is more close to the reality. So if your user is not getting result, it will simply keep pressing F5, right? So this is what simulates. It keeps the rate that you want and doesn't care about virtual users. This is a lot better. So close should be like that. And if the response times goes down, also the iteration arrival rate, iteration is sending the messages to the server, will also go down. So the test system is affected by the end system. With the open model, this doesn't happen. If it needs more views, more virtual users to do that, it will create them without you having to do absolutely anything. And that's, for us and for real testing, this is fantastic. Because if you provoke that and you have a closed system, it will be affected. Your test will be affected by the responsiveness of the SUT, the system under test. With the open model, it will not. And that's really good. So let's take a look. So the close we have already seen, and we will take a look at the open. In this case, ramping arrival rate. We care only about the rate that we hit the test system. In this case, we pre-allocate some views, so we don't run out of virtual users. 100 in this case, and we will be 10 seconds with 5, that we start at 5 also, and then we will go up to 10 on the other 10 seconds. So let's try it, 08. Okay, 6, run. I will do 09. Okay. Oh, yes. All right. What is funny that even we are doing 5 iterations per second, it's keeping up and it's taking care of getting as much virtual users as he needs to use, which is pretty cool. And then it waits a bit to ramp and stop them gracefully. And yeah, this way is a lot better way to do tests. So I recommend to go with the open model. That's definitely better. So we are almost on there, on a bit on seeing how does K6 work. And we will go and take a look now on how to integrate it with Azure DevOps. So I have here in a simple repository where I created a folder. The folder is performance, where I put what is some code I will mention later, the Multistrada template, a template I made as open source in the frame of Swiss Life. So its code is public in GitHub and has examples on how to do a bit of preparation to work on different environments, get them as parameters, and put the code a bit secure, and do, well, different scenarios there. And also different types of tests. So it's meant to simulate a smoke test, a load test, or soak test, and then some stress test. And then I have an Azure Pipeline here that it's simply, I have published it as a pipeline. So let's take a look at it from where it is. Edit. Yep. And here, this pipeline, which is also part of the code, so it can evolve. I'm using Ubuntu latest, and simply I'm putting some script to display what it's doing. And I'm checking if the directory performance that I showed you before in the code exists. And then I set a variable performance to true. And if this variable is true, I publish the folder performance under the artifact name perf_test. Of course, if you use multi-stage pipelines, you could do it here, but I wanted to show as well how to do that with the releases. And here, I simply put a very simple step, which is part when this release is, well, this pipeline is built, it will trigger this as well, and it has some jobs. The first thing is that I run this in Ubuntu, and I do an install of K6, and I put some code here to install it on this Ubuntu. This code, if you go to k6.io and you go to open source, and you go and click on download, is exactly the same for installing to Ubuntu. That it is there. And it's good if you do that, that sometimes this may change. So some months ago, they changed the server. So we had to update that. So it's something to keep a good eye on. And once this is done, we can check that the version responds properly. And then we execute a shakedown test. Here we have our friend K6 space run and the name of the script. But then I use -e token username. And if you know Azure DevOps, you know that these are variables. So I'm putting as parameters the username, the password, the test that I want to run, and the environment I want this to run in. And in variables, I have them. So I have here, I want to run this on the test environment. I want to run this as a smoke. I want to run the smoke test that I show. And then I have some secrets, the password and the username. All right. And then nothing more. If this fails, it will simply fail. And here we can see an example and see that everything succeeded. This will basically fail if the threshold fails. As simple as that. And how it looks is essentially the same, a bit more verbose, because I had a bit more in these tests, but at the end, you can see that everything simply passes. And that's how you integrate K6 with Azure DevOps. Nothing more, nothing less. I believe it's pretty simple. You can do that pretty easily here. Apart from that, I like to show a bit this multi-scenario template that I mentioned. So we have at Swiss Life push for open source. So we are investing like half a day per week in innovation. And mostly a lot of us do that to push open source projects that are, of course, beneficial to the company. This has the goal, this multi-scenario template is a K6 template that you can get and download and has a lot of the things ready for you to extend with the goal of accelerating performance testing adoption, learning, and of course, reuse of this template. And if you like, you can contribute it and give it a star if you want, right? If we go back here, this is on the scope of Swiss Life open source, which we have tools like, for example, testing framework for containerized services, Snapshooter for snapshot testing, recently some other tools for managing configuration or IDOps for identity resource management. And one of them, a bit more below, is the K6 multi-scenario template. Here, you have Learn K6 with examples I show you, so you can try them out. The servers that this is hitting are up there. And the nice thing is this K6 multi-scenario template. I put here some explanations and text how to get started. But nice thing is if we go and open it, I will open it on a code editor, multi-scenario template. It manages some input arguments, has a bit of examples on how to create custom counters and trends. So one for each service or scenario that you have. So that's, to me, a good practice. How to use different types of tests like soak, stress, load, etc. And then this thing is, for me, it's pretty cool. Instead of creating one different script, there is like an example on how to define this on the same code for different tests, like a smoke test, which is a simple test that checks the stability of your system, to do a load test, or a very long running test like a soak test, or the stress test when you want. Let's take a look at the stress. When you want to really stress out your servers and see which are the limits of your server, when does it break, right? Which is interesting to see which is the weakest part of your system. So this is all here. It's open source. And there is also some examples of different functions that you can reuse, and examples on how to access UI that we have not seen today, how to access a REST endpoint, and also GraphQL, because we do a lot with that there. And also it includes like an example for authentication and getting the token, which is on the setup part. So you can check that here. We get the token and we send it to all the other functions. So you can execute the test with the same authenticated user. Of course, it all depends what you want to do, but this is just one scenario or example. And if you like it, you can extend it. So, all right, that's it for this evening. As the takeaways, I would like to recommend, well, first is you should do performance testing unless you want surprises or stress. If you don't like that, you better start doing stress or load testing. K6 work really, really well for me. It's really good. So I recommend it as a tool. So I'm really happy with it. And also the community. I was in touch with some of the people there, and I would say that the community there, they have a Slack channel that they are pretty responsive. They have some forums that they are also very responsive. And so far, pretty amazing people there. You should also apply performance testing since the beginning. And yeah, why not have quality since the start? I mean, the same as testing, right? Or TDD, test-driven development. And of course, if you like it and it is useful for you, use the K6 template, the multi-scenario template. And if you want or add some function, it would be great if you can contribute back to improve it. And then let's go to the questions.
Oh. So, what an awesome talk. We have a bunch of questions. So, Bram, you had one. So, ask him.
Yeah, I was wondering what the key differences are between K6 and, for example, JMeter.
Yeah, that's a very good question. JMeter has been on the market for a long time. It's UI driven, while K6 is code, right? I like code because I'm a developer myself. And with JMeter, you are bound to the tool and the format can change. Apart, the format of JMeter is unreadable. So, well, you can, that's discussable, but it's like having, you know, resource manager template, right? Some people say, oh, well, if you create just a resource group, that's readable, yes, but do a bit more than that. And, well, it's really not bearable to read that. So, yeah. And for one, you read it as a user or as a coder, and you can figure out what it does. I like that part. And integrating that with Azure DevOps or any pipeline DevOps of any technology is a breeze. Apart from that, the performance, the JMeter, it's your memory. It's like SQL Server. And the performance and throughput is quite better. So I think just this alone, it makes it a lot better to my point of view.
Okay.
All right.
Thanks.
Then we also have the question, does K6 support distributed load testing for instance agents?
That's also a very good question. It does, but so you have, what we have been showing today is the open source version. If you use the commercial version, you can do that, and you can even simulate your system under test, your SUT, from different parts of the world. So you can simulate it being hidden from Canada, from China, or from wherever you want. So you can do that with the commercial part. With the open source, you have what is called the K6 operator. It is an open source project where you can distribute that on different containers. You have to orchestrate that yourself, but you can do it.
Okay, cool. And then also, can we get the results in a format that that we can see, like a drawing or like a diagram?
Mm-hmm.
Because now I just saw something on an editor or in a terminal. And
Yes, definitely. You can do that. And for example, recently K6 was bought by Grafana, and there has been since ever integration with Grafana. So you can put the output to a time series database, and which is integrated with Grafana, but also a lot of other observability platforms. I think now it's the trend. We should call them observability platforms. So you can do that in many, many ways. Yes. Also, you can export the results as JSON and analyze them with Excel if you want.
Okay. Then there is also a question from Nick. I would like to know how many VCUs can be used from a self-hosted solution that is initiated after the deployment in a Docker container.
Mm-hmm. Okay. There is no limit to the VUs or virtual users. It depends on the hardware that you have. So I believe that I show a graph that was about 11,000 in the same computer. But I believe that they have reached like 30,000 in a high-end computer as well. And apart from that, you can distribute the load in different containers and have as much throughput as you want or you need. Of course, you will need more containers, right? But you can do it and you can scale it. And the last point is the performance results are influenced by the system requirements. Well, I think you should ask that to the requirement engineer, right? If I'm not sure if this is system requirements or requirements. So if it's something that it's a requirement set, or I'm not understanding fully this last part, but of course, if we're talking that the performance results are influenced, if you're using the open model, you will decouple. So you have a system that is sending like one user sending a request. If it's a closed model and this system is taking like 5 or 10 seconds to respond, obviously it will be every 10 seconds, it will take 10 seconds until the test system gets back to control and can send another test. But if we have the open model and you say 1 per second, it will be sent 1 per second. Every second it will get one request. In this case, it will not be influenced. I hope this responds the question.
Okay. So then I have another one. So I want to start with the load testing, right? How many views should I use to get started with?
How many EBUs?
Yeah.
Oh, depends. I mean, where is your test running? Probably in your local machine, right?
Or on the K6 Cloud?
Yeah, I always go slow, so you can have many surprises, right? So I would, on my humble experience, I start with 1, then I wait some 1 or 5 minutes, then I increase it. Sometimes I'm daring, but sometimes I'm not, right? It depends on the system, what it's doing. And usually I make the question, how many users or how many clients will use this API? So we have an estimation. For example, if we have a maximum of 200 calls per hour, you can distribute that. Or you can let K6 to distribute that. And then you have a point. You know if it will be fit for a purpose or not. If you know that, then that's your go-to on throughput.
Okay, and would I test against my production environment, or do I then make my own DDoS?
Well, you should get approval for that. I mean, that's a bit of a challenge, but the ideal thing is that you get an environment which is exactly the same as production for testing, right? Or and also, of course, be ready to swap, right?
Yeah. Okay. Yeah, and to stop the test.
Yeah. I would not test in production. That's a very bad idea. But to test in an environment which is production-like, that's a very good idea. Of course, you have to also to simulate the data load there, because if you have a database with, I don't know, for example, 180 days of data, and you have to keep that, you have to take in mind that your database will grow. So you have to create the amount of data that your users will create in 180 days. That's usually something that we overlook as performance testers. We check the throughput, but we are not checking the database throughput.
Yeah. Yeah, and then you have a very fast front end, and your back end is like going, what is this stuff?
Yes.
All right.
Exactly.
So just to plug this from Floor, there will be some kind of announcement at ObservabilityCon. So if you're all still here and you have nothing to do this evening, check that out. I think it's in half an hour-ish. Mm-hmm. So check ObservabilityCon. If you haven't done so yet, please follow this channel, because the more people that do will help us to get more discovery. In December, we will not host a meetup, I think, because the holiday season and everybody is tired and that kind of stuff. So we will be back in January. Keep an eye on the meetup page for that. And I would like to thank Jose. I did pronounce it well, I hope.
That's perfect.
Okay, yeah, cool. For this awesome talk and showing us how K6 can be used also with Azure DevOps. I do see a question popping in. Just having a test env as a production is not always an option. Okay. What about create? Oh, exactly that. I would do that and use some kind of Terraform like to spin it up and break it down after the test is done to keep the cost low. Yeah. But you can only do that in the era of cloud, right? So if you're not working in the cloud yet, that might be a bit harder.
Yes. I think Sergio is perfectly fine, and you are absolutely correct as well. It's the power of the cloud, elasticity, right?
Yeah. And yeah, so all the things that you have seen is with the open source version of K6. So you should be able to get going free of any charge. Well, you do have to pay for your build minutes, right? But
yes.
After that, you should be good. And here's the link.
I saw one more question from Martijn. He was asking if K6 supports ramp testing.
Let me get it.
What do we mean with that? Ramp testing?
Yeah.
Yeah, so ramp up and ramp down.
Yeah, of course. That's what we saw, right? We saw this VU ramping executor, which essentially you put initially, you have one view, and in 10 seconds you have 10 views, and it will ramp them up and then ramp them down. That's what you have, the different stages that we saw before.
Cool. All right. Cool. With this, I will bring this to an end. Once again, thank you so much for your talk. I hope that everybody in the chat and in the channel has a great idea now on how to use K6, and everyone will start using some kind of load testing. And I will see all of you at 30 minutes to see what cool announcement we get from ObservabilityCon.
I am curious now.
All right, people. Thank you so much for watching, and see you all next time.
Thank you, Daniel.
Good night.
Was a pleasure.
Good night.